Today's topic has come up in the past. When we reviewed the Gigabyte Gaming 7 motherboard for the 7700K, we found that its auto voltage curve ramped the CPU into unreasonably high temperatures for no performance gain when compared to competing options, even manual options. Gigabyte later fixed that auto voltage, and we now use the Gaming 7 for GPU testing regularly and like the board a lot, but we're exploring a similar scenario with the i9-7960X, which also applies to the 7980XE and 7900X. We'll be demonstrating how motherboard and BIOS revisions can heavily impact the interlinked thermal, power, and voltage values when using auto settings. Before getting to that, this video is brought to you by Synergy, the software that lets you share a keyboard and mouse between multiple systems. If you have limited desk space and multiple computers to command, Synergy removes the need for separate peripherals or a KVM and works as over-the-network software. Use our link below to get 50% off the Home or Pro version with SSL. The point of this testing is to show, well, it's really to revisit a few things. So we did all that delidding testing with the i9 CPUs, and the testing there was, it was either overclocked and overvolted, or it was 3.6 gigahertz, so not really overclocked, if at all, depending on CPU, and a fixed 1.15 voltage ID. The 1.15 VID, as noted in those content pieces, was higher than necessary, but it was chosen because it would stay fixed at that voltage without moving at all, and that's what you want when you're doing comparatives between two thermal interfaces. You really don't want auto taking control of things, because who knows what it's going to do, who knows if it's going to respond differently under different thermal scenarios, or if it just decides to do something different one time versus the other, which happens basically every time you run a test with auto voltages, with the exception of the Gigabyte board we'll be looking at in a moment. But the point, though, is to revisit some of that with auto settings, not for purposes of showing thermals necessarily as the main item we're looking at, but more for purposes of showing how a motherboard and its auto settings with the voltage lookup tables can pretty significantly impact your performance in a lot of ways. It can impact power consumption directly. It can and will impact thermals directly. As your power output in watts goes up, so too goes up the thermal output, or the measured thermals of the CPU, because you have to dissipate more heat, and it affects a lot of things. So hopefully this educates a bit on doing some manual tuning yourself whenever you buy any processor, because auto voltages are often a bit excessive, but it's to make sure they can support the speeds and the advertised specs across all CPUs and motherboards, because there's some variance, of course, CPU to CPU. So the boards we're looking at, we have 5 today. Well, we have 3 boards with 5 configurations across them. So the Asus Rampage 6 Extreme was our primary board for the review, the liquid metal versus TIM testing, and everything else we've done so far with the 7980 and 7960 CPUs. And then we also, on that, we have the 0802 BIOS revision, which is the latest EFI from Asus. And this board was joined by the Asus Prime X299 Deluxe motherboard, a lower end board, and that uses both the pre-7980XE launch EFI version and the newest 0802 revision. The Gigabyte board, the Gaming 9, joins this one, and for that we're using the latest EFI revision F6 and the launch 7900X EFI that was sent to press. I don't have the specific number on that. It was a press launch. But the point of doing these is the 7900X launch EFI for the Asus Prime board and for the Gigabyte Gaming 9 board basically came out before the 7980XE really existed to the public or was finalized. And that means there's no profile tuning for that CPU, the 18-core or the 16-core CPUs. It was built for the 10-core. So we should see different results, because the BIOS should respond differently based on if it has that voltage lookup table for that specific CPU. We're just going to be focusing on Blender for most of these tests. We did use Prime 95 for everything as well. It's a great test, but Prime does a lot of stuff that is kind of difficult to control for once you start getting into this kind of testing. So it does power cycling, which means that in some head-to-head tests, you end up with occasionally way more amperage going through on one test pass than the other, based on a couple of different behaviors of the software. So we did run Prime, but we ended up just going with Blender for everything, because Blender, once it ramps up and starts going, 9 times out of 10, it's a perfectly fixed, pretty much constant current going down the EPS 12-volt cables. The load doesn't really change, as long as the project file stays the same. The other 1 out of 10 times, we will see really spiked loads or higher thermals, but you develop an eye for that and then eliminate those results as outliers as necessary for this type of testing. So we're using the Intel i9-7960X for these tests, and we're using the liquid metal modded version. Can't really go back on that for the most part, so we're stuck with it and we're using it for these tests. And we're going to start with voltage ID behavior on auto settings between the 3 motherboards with the 5 different EFI versions. Voltage ID behavior directly influences everything else. So using all auto settings with XMP1 and maxed fan settings, those are the only changes we made. The first Gaming 9 test with pre-launch BIOS pegs VID at roughly 1.01 volts, and that's again VID for the entire test. This never really changes. It's a perfectly flat line for the most part. The Asus Rampage motherboard fluctuates and bounced around between 0.91 VID and 1.0 VID, generally sticking to 0.96 to 0.97 for the entirety of the test if we're looking at the more frequent numbers. We only started using this board with the 7960X launch, and it had the latest 0802 BIOS already, so the board has a tune for the CPU and seems to behave as you'd expect. The Asus Prime board with the original EFI also bounced around a lot, at least a lot more than the version with the EFI version 0802, and we averaged 0.89 to 0.96 VID with the pre-launch version and 0.96 to 1.0 with the 0802 version. The most noticeable jump is the Gigabyte Gaming 9 EFI update to version F6 from the 7900X reviewer EFI version. We've moved from 1.012 VID to a range of 1.065 to 1.08 voltage ID, depending on which core is measured. This has a more significant impact on both power and thermals than any of the previous tests. For power testing, we're measuring at the EPS 12 volt rails, which means that the bulk of our power consumption is the CPU. Some other board components will also pull down this power cable, but nothing close to the CPU's consumption. That said, there is some error involved in changing motherboards for power tests, even when measuring at EPS 12 volt cables, but not really that much comparatively. The Rampage 6 Extreme on Auto and 7960X are measuring about 217 watts at the EPS 12 volt cables. Again, this is under auto conditions and with a blender workload, so it's not the most power we could pull, but also not the least. The power consumption will change based on the application used, and as we're showing here, the motherboard. The Asus Prime board with the first EFI revision, which ran overall lower voltages of 0.89 to 0.96 versus the average 0.91 to 0.98 of the Rampage, managed to consume about 206 watts on average. Updating EFI to version 0802 moved our VID to 0.96 to 1.0 as the range, which consequently shifted power consumption to 222 watts. That's just from an EFI change on the same board. The Gigabyte Gaming 9 with its original EFI had a higher sustained voltage ID of 1.012 constantly, which produced a higher power consumption, and the Gaming 9 with its EFI version updated measured at 230 watts. So that's now 30 watts more than the lowest board and lowest EFI, and about 15 watts higher than the previous 3 configuration average. We ran 2 tests of the Gaming 9 with version F6 since the results were so much higher in power consumption than the others, and we wanted to double check them. The tests had some variance, but were overall much higher in power consumption anyway. We were between 255 and 268 watts depending on which test, and that's now 50 to 60 watts higher than the lowest board on the stack, which shows just how much auto voltage tables can impact results, and is precisely why we fix voltages for things like comparative testing between TIM and liquid metal. But obviously you'd still want to test auto for the motherboard reviews, or just to figure out what the CPU and board will do in a user scenario without tuning. Thermally, voltage of course impacts results directly. We have a tolerance of plus or minus 3 degrees Celsius for ambient and thermal application differences here, but can still see gaps in performance. The Rampage 6 cooled the best. Some of this is because of the spacing of the VRMs from the socket, and landed around 40 to 44 degrees Celsius. The Gaming 9 with launch EFI plotted at 42 to 46 degrees Celsius, again all auto settings, with the Asus Prime testing at around 46.5 degrees Celsius for 0802. The Gigabyte Gaming 9 with the F6 EFI plotted at around 50 to 51 degrees C for a 10 degree gap versus the lowest temperature on the plot. So that's a pretty big deal. That's what happens when your voltage lookup table, when it's set to auto and the motherboard vendor is a little aggressive on the voltage table, that's what you get. Higher wattage consumed, higher thermals as a result, and the performance is the same. As long as all the cores can sustain their frequency, it doesn't matter if you push more volts through it. It's just burning power for the sake of burning power. So there's an argument here that by taking a conservatively high voltage value, VID or VCore, whatever, depending on what you're working with, a conservatively high value means that probably you're going to support every die that comes off the line, whether it's low quality or high quality. Sure. But also there's kind of a limit here to what's reasonable. So Gigabyte, once again, is pulling a little bit more than they need to. It's not nearly as bad as the Gaming 7 Z270 motherboard. A little bit higher, but not terrible. Still though, there's a 10-degree difference there. So if you get that Gaming 9 board or already have it, we would recommend manually dropping the VID setting until it stops being stable, until you're either clock dropping or crashing, and then increase it a little bit. It should still be lower than auto, and you'll have lower thermals for it and lower power consumption for it, and both of those things are good, especially for the life of your liquid cooler if you have one. But the point isn't really to look at the motherboard specifically, although I mean, there's a note for Gigabyte if you're watching this video. Just, again, look at the same thing as you looked at for Z270. But that's not the point. The point is motherboard changes matter a lot. They always have, but we just figured we'd show it on a CPU that's particularly power hungry because it exaggerates the results a little bit. And also kind of as a reminder of, hey, this is why when you're testing something like a CPU cooler, a thermal interface, or anything in between like a shim, any kind of cooling dissipation test that does not involve a review of the CPU specifically should be done with the same motherboard every time, with a fixed voltage, a fixed frequency, all manually set, ideally a little bit conservatively high on the voltage, like Gigabyte's doing here, just to make sure nothing changes. So that's why we do that for those tests. But yeah, depending on board, you probably want to manually tune that voltage down to see where it's still stable with the least amount of voltage going to the CPU if you're using it in the stock settings without any overclocking. Another note here. So I wanted to quickly show some of our auto test temperatures for the 7960X, a little bit for the 7980XE. We never did get to run all the liquid metal tests because, I mean, I ran them and then left to go to do Linus's thing. But we've got those set to auto. And before showing the charts, didn't show these in the original review because, again, they were set to auto. So the voltage changes a bit from test to test, which means that it's not a fair or valid comparison if you're trying to test liquid metal efficacy versus TIM, because the voltage properties are changing. So you're not testing the interface material anymore. You're just kind of testing the temperature at whatever voltage it decides to run at for that particular test pass, and it will change pass to pass regardless of the interface material. But we can show those charts. So this is what the auto temperatures look like. We'll show prime. We can show blender as well at some point. Basically, it's a lot lower than with the fixed voltages and frequencies, of course, as you would expect. But this demonstrates, even still, even with the variable voltage setting that's auto and kind of bouncing around, we're still seeing improvements with liquid metal. If you overclock, you should definitely put liquid metal on there because, as shown in the original content piece, once we were overclocking to 4.6, 4.7 gigahertz with 1.22 to 1.24 voltage ID, 7900X I think was at 1.175, is pretty good chip. Even with those settings, or especially with those settings, that's when you should start caring about either delidding and replacing with a better TIM, more on that soon, or delidding and replacing with liquid metal. Because dropping even 10 degrees, which was about the lowest we dropped at that point with the overclocks, even dropping 10 degrees is a huge deal. I mean, that's the difference between your CPU being in the 90s for degrees Celsius on an open air bench where ambient is 24 and being in the 80s. And you might ask, who cares if it's in the 90s or 80s? Well, Who cares is your liquid cooler and the manufacturer, because they're not going to want to fulfill your RMA when it dies because the liquid was running at 60 degrees Celsius, which is above or at spec. That's who cares. So it helps to bring down the temperatures. It's unfortunate that you have to do it yourself if you're overclocking. But if you're not overclocking, you're fine. You don't need to delid the thing. If you are, and you're using a CLC that's either, well, so a few things here. One, either you're using a huge CLC like a 360 or a 420 because you need to deal with all that heat and your liquid temperatures are probably a bit better and your fan noise is higher because you're going to need it. Or you're using a smaller CLC and you're pushing the limit of what the pump realistically should be handling, even if your CPU looks like it's okay. So in both those scenarios, you can improve things by delidding, changing the interface, and either you lower your noise levels and improve your cooling, which is probable, or you can step down your cooling solution to something cheaper, maybe a 240, maybe a 280 with slower fans, and still be better off than Tim. But this isn't news. We showed this in the review and in the part 1 of the thermal thing. But I mean, the point again is motherboards impact things a lot. Do some manual tuning on it, even if you're not overclocking. If you're not overclocking at all, thermally, you're going to be in better shape than what we show when overclocking or when overvolting. But even still, even with that variable voltage, we were plotting improvements with liquid metal. It just doesn't look as big because the voltage is bouncing around, so who knows what it's doing. But that's all for this one. As always, you can check the article in the description below, gamersnexus.net for that if you prefer reading, or we would recommend checking out parts 1 and 2 of this, which we'll put in the end slate. You can go to patreon.com/gamersnexus to help us out directly. As always, it is a big help at this point. Or store.gamersnexus.net to pick up a shirt like this one, which we've just restocked. This is the Graph logo, and I think we have it in tri-blends as well at this point. So thank you for watching. Subscribe for more. I'll see you all next time.